Alright guys, going to have a little quick instructional video to go over the applications of the law of cosines. This will also serve to review the law of cosine just in general. So let us start off. I'm actually going over checkpoint number 3. It's on page 728. So if you want to read over that problem before we go through it, that'd be good. And as always, you can pause this video at any time to do your own calculations, then hit play to see if my calculations end up matching up with yours. So checkpoint 3, I didn't write out the whole problem, but I had the textbook off camera right now, so I'll just read it to you guys real quick. It says two airplanes leave an airport at the same time on different runways. One flies directly north at 400 miles per hour. The other airplane flies at a bearing of 75 degrees northeast at 350 miles per hour. How far apart will the airplanes be after 2 hours? So this is kind of what our image looks like. We have two planes leaving from an airport going two different directions. This is going to cause a triangle to be formed. And this triangle is going to have that SAS, or side angle side relationship, that we use when we use law of cosines. So this vertex right here represents the original airport. We have two planes flying. Now, they've been flying for 2 hours. So if I know that this plane's been traveling at a rate of 400 miles per hour and been traveling for 2 hours, we know that plane 1 is 800 miles from the original airport. Likewise, the second plane has been traveling at a rate of 350 miles per hour for 2 hours. So that means that plane is 700 miles from the original airport. Our goal is actually try to figure out how far away these two planes are from each other. Now, we know the first plane flew directly north, and the other one had that bearing of 75 degrees east of north. So we know that that's 75 degrees right here. You might want to review how we read those bearings. So when we see something like this, all our bearings start from the north-south line. So from the vertical north and south on our compass. This just means 75 degrees east of north. So instead of due north, we're 75 degrees east of north. That's where we're getting that bearing right there. And if you want to see it in terms of a compass, this is east, north. It's 75 degrees east of north. Okay? So quick review on bearings. Now we have this SAS setup. I'm looking to figure out this side. We're going to label this X. So the law of cosine states that this side right here, X, we can write as X squared is equal to 800 squared plus 700 squared minus 1/2 800 times 700 times the cosine of 75 degrees. All right? Now, this is our formula. To solve this formula, this is where we have to actually just go through the math and actually do the math related to it. So this is where, yes, you're probably going to have a calculator on hand because I'm not going to write out every single step. So this might be a good time to pause the video and see if you can come up with the same calculations. Make sure your calculator is in degrees. As we solve, we'll get X squared equals, and I'm just copying this directly off my calculator. Now, I'm just kind of rounding this off I'm not rounding. I'm just cutting off the writing. I would leave this answer in my calculator and then use the square root of the answer key, or you can use the STO or store function on your calculator because I don't want to round in the middle of a problem. But I do want to take the square root of each side to figure out what X is. We're going to come up with that X is approximately equal to 916.6 miles. Depending on how we would want to round that, that would be instructed to you guys via me or via Math Excel. But this is what it looks like overall. Again, might want to go back, do this calculation on your own so you come up with that example as well. All right, guys, good luck on the Math Excel and message me if you need any help.